Hi guys, my name is Parag and welcome back in my new video. In this video, we are going to discuss about a numerical based on two-hinge arch. Okay, in this structural analysis series, okay, I have explained you lots of type of numerical for the strain energy, three movement theorem, and the strain energy slope deflections method. And here now we are going to start the two-hinge arch numerical, which is definitely very interesting, and I made it so easy for you so you can easily solve it in your numerical. Okay, so let's get started. So we will first start with the numerical written over here, because this type of the theory numerical will always give lots of information to solve the numerical. Okay, now let's get started. So a two-hinge parabolic arch, 20-meter span with a central rise of 5 meter, carries UDL of 40 kilonewton per meter. So see guys, there is a lots of information given in this numerical. So first of all, the first given information is it is a two hinge, okay, two hinge parabolic, okay, parabolic arch, okay. Then it's 20-meter span, so its distance is 20 meter of span, okay. Next distance is with a central rise means the height, okay. So from here to here, this rise, this height is called as a central rise. So central rise, okay, which called h, which is 5 meter, carries a UDL of 40 kilonewton per meter. It means they have also given us the load. So the load is 40 kilonewton per meter, but now they have mentioned that 40 kilonewton per meter over the right half span. It means total distance is 20 meters, so half distance is 20 divided by 2. It means 10 meters. So only on 10 meter you need to provide 40 kilonewton per meter of load. Okay. Now they have provided one condition: if I equals to IC sec theta with usual rotations. Usual rotations means this side will having clockwise as a positive, anti-clockwise as a negative, and this side will be having anti-clockwise as a positive and clockwise as a negative rotations, right? So we need to calculate horizontal thrust. So horizontal thrust, okay, horizontal thrust is always mentioned by h. So we need to calculate the h, okay, as well as maximum positive and maximum negative bending moment over the arch. So with based on these available data, we need to solve this numerical. Okay, we need to understand this numerical, because in your examinations no one provide this sort of diagrams. Okay, in very few numericals the diagram is available, but uh, in the maximum numericals only theory is given. So based on the theory you need to draw this type of diagram. Okay, so let's just understand this diagram. So this is point A, this is point B. So in this both point, we know that the 20 meters is a span. So we have just made this a 20-meter span. Okay. Now after mentioning this 20-meter span, okay, we also draw an arch which is like this. Okay. Now after drawing of this arch, what was the load condition? It is a 40 kilonewton per meter is a load conditions which is mentioned. But now where we need to assign? So 40 kilonewton per meter over the right half span. So if I just do this, this is the left side, this is the right side. Okay. So on the right side we need to provide the uniformly distributed load, right? So what I'm gonna do is, okay, so on this right side, I have assigned 40 kilonewton per meter of uniformly distributed load. Okay, now after that, they also mention the central rise of 5 meters means this h, this height is also they mention as a 5 meter. Okay, don't worry, this notes will be available to you on my website, which is www, okay, dot civilnotes.com. Okay, civilnotes.com. Right? So visit this website. You will be having lots of civil engineering notes and videos. Okay. Now, so you have or you got these things like what we have to do and how we were gonna calculate the maximum and minimum bending moment and the horizontal thrust. This is gonna start right now. So the step number one is first understand the numerical and draw the diagram, because diagram will help you to understand the calculation of the movement, reactions and everything. Okay. Now the step number one after that is calculation for vertical clearances, okay, which is VA and VB using condition of equilibrium. So what is this condition of equilibrium, guys? Let me tell you very single thing. If there is a 100 kilonewton load, okay, is coming from top to bottom, so that load should be equals to whatever load or whatever forces is going from down to up, that's equals to 0. So this is what a condition of equilibrium we are understanding for this type of numericals, right? So you can see that why I have written only two forces over here and only two forces over here, because here it is mentioned that a two-hinge parabolic arch. So two-hinge parabolic arch means whenever there is a hinge support, okay, so hinge support always carry a horizontal force and a vertical force. Okay, so there is only two forces should execute or available at that point for solving whole this parabolic arch numerical, right? So if I just remove all these things, right? So first of all, what we have to do is we need to calculate the vertical clearances VA and VB. So this VA value and this VB value we need to calculate. Okay? Based on what? Based on the condition of equilibrium. So for that what we'll do is we are gonna do a summation of force along the y direction equals to 0. So whatever forces is going on a from top to bottom will be in a positive manner, and the forces are coming from bottom to top will be in the negative sign, right? So what we are going to do is we are just going to distribute this arch in a beam type of shape. So I just made a straight line of the 20 meter, and on the 10 meter over 10 meter we have assigned the UDL. Okay, so these changes we made, right? So what we are going to do is now just look at this beam. So as I said, the forces is going from top to bottom in a positive sign, and the forces is coming from top to bottom, okay, are in a negative sign. So VA is going from bottom to top, so it is positive. VB is going from bottom to top, so it is positive. But UDL is coming from top to bottom, which is in the negative sign, right? So what will happen, guys? So you need to just understand the sign representation. It is VA plus VB minus 40 into 10. Why 10? Because when there is a UDL and if we want to convert UDL into the point load, we need to multiply it by that distance. Okay, so 40 into 10 is the distance. If there is only point load mentioned, so there is no worry about it. Just put into it and just make it a whatever load is given to you. But if there is a UDL is given, so you should look into it what is the distance mentioned there, right? So VA plus VB minus, why minus? Because force is coming from top to bottom, which is in a negative sign. Okay, so VA plus VB minus 400 equals to 0. 40 into 10 become 400, right? So VA plus VB equals to 400. This is the first equation, guys, we have received. Okay, now let's understand. Now we have got one equation. Now we need to also need to identify one of the unknown value from this beam. So only after that we can get the another unknown value. Okay, for that you need to do the second sub step, which is taking a movement at any point. So I'm going to take a movement on the point A. If I'm going to take movement at point A, so whatever the forces or reactions available on that point become 0, because there is no any perpendicular distance, okay, on point A. So if we are going to take movement on point A, so how it will go? See, VB, okay, in anti-clockwise directions. So minus of VB into what is the distance? 10 plus 10, 20. So movement is always calculated as force into perpendicular distance. Okay, so if I'm gonna take movement at a point, okay, and this is something x load and distance between this is y, so my movement will be x into y, whatever the sign over there. Okay, if this is load moving like this, so this is positive. If the load moving like this, so it become negative. Okay, so this is what the sign convention we also need to understand. So in this case, what is happening is we are taking movement at point A. Okay, so it is minus of VB into 20. Okay, plus 40 into 10. Okay, see, 40 into 10 we convert into the point load. Now we need to see why 10 divided by 2. Why 10 divided by 2? Because 10 divided by 2 because this point load will act in the middle of this section. Now once convert into the point load. Okay, so this is become like this. Okay, this is A, this is B, okay, this is C point, but now this become 400 and this 10 will distribute in 5 and this is 10. So that's why 40 into 10 converted into the proper load, point load, in bracket, this is a distance which is 10 divided by 2 plus 10 up to this distance, okay, is equals to 0. I hope you got this one, right? Now, after this, let's solve again. So minus of 20 VB plus 6000 equals to 0. Now you see guys, now you have 6000 just shift there, okay, and divided by 20, so you will get a value of VB as a 300. Now you have a value of VB as a 300, just put this value in this equation, so you will get a value for VA which is 100 kilonewton. So now you have that particular values, okay, which for this which I have taken this step. I know my video is very lengthy, but I'm trying to explain you how you can solve the numerical like this, okay. Now let's go to the next step. Okay, so in the next step guys, you can see we need to calculate the equation for parabolic arch in term of x. Now we need to understand, okay, we have a parabolic arch. So now we also need to understand that how much parabolic arch equation, because parabolic equation we need to identify, right? Because there is a curve into it. So that curve we need to identify, and how we do that? That's very easy and very simple step. For that you need to just learn one formula, which is y equals to 4hx in bracket L minus x divided by x L square. Okay, so this formula I'll just write here. Oh, sorry, I'll just write here, which is y equals to 4 into h. H is what? The height. Okay, this particular height. Okay, so y equals to h into x is a unknown, right? X is a unknown, in bracket L is a total length minus of x, x is again an unknown, divided by L is a total distance and its square. So this formula you need to learn, because this formula only give you the parabolic arch equation. So now just put the value into it. It's very simple. So 4 will be as it is into 5. 5 is a height. So this height, the parabolic arch height, we have considered 5 meter. Okay, we have written here x will be as it is. Now L is replaced by 20, 20 minus of x divided by 20 square. So now just solve it. Okay, so how it will solve? So 4 into 5, 20 x, right? So it will like 20. So I'll just solve it for you. So it become 20, okay, x in bracket 20 minus x divided by 20 square. So this square and this 20 will get cancelled. Okay, so what will you have? You have x in bracket 20 minus x divided by 20. Now just multiply this x in the to the bracket. So it is 20x minus x square divided by 20. Got it? So this only we have. So we got this equation of the parabolic, like we got the parabolic arch equation. Now the step number 3, which is our first calculation, which is called as a horizontal thrust. So to calculate the horizontal thrust, which always represented by h, right? And as per our numerical, we need to calculate horizontal thrust over here, right? So how we are going to do this? So first of all, just take that beam diagram which you have drawn, okay, and just write over here, because that only help you to solve this type of the numericals, okay. So for that you need to prepare a table which mention the portions, okay, origin, limit and the moment equation, okay. So what we have done here is we need to identify the sections in our beam, like strain energy method, okay. So see guys, a very simple example I'll just give it to you, okay. So this is one beam, okay, and this is another point. So this is point A, this is B and this is C point. So there is a one section which is AC, another section is CB, okay. If there is a three load, like three support, okay, so this is first section, this is second section, this is the third section. So how many section will be in that span, okay, that much portion will create, that much movement equation will also create, okay. So this understanding you should carry forward to take place this horizontal thrust calculation, okay. Now let's solve this moving further. Now what we have done is we have drawn this total diagram by mentioning the value of VA and value of VB over here, because that value is not now gonna help us to solve this numerical, okay. So now we have just written AC is our first portion, so from this to this we are consider the one first portion, okay, which is the AC. Now in AC we have just draw one section which is an unknown section called X, and the distance from A to that section is also unknown, because we don't know what is the distance into it. So we just mention it as a X, right? So we just take a portion AC and we know that the origin of this portion is A, right? So after that we also need to mention the limit, like the strain energy method, okay. So limit is what? Here it is 0, but up to C point the distance is 10 meter, okay. So total span distance is 10 meter, right? So the limit is 0 to 10 meter. Now we need to take the moment, okay. So your starting point is this and you are proceeding up to this point. So you should take moment from A, right? So movement from A, how it will take? So where you need to take movement, you need to only take the movement. Just example, this is the A value, this is the X distance, and this is the X section. So you need to take the movement at this point, okay. So we have a VA which is 100 kilonewton. So 100 kilonewton moving in a clockwise direction with a distance of x. It means 100x is the movement. So that's why I have mentioned 100x here over here. Okay. I hope you understand this. Now moving further guys, let's take the another one which is the another section B to C, okay. But now we are taking this sort of sections, our rotations will change. If we just moving from this point till the last point, so our clockwise direction will be positive and anti-clockwise will be negative. But in this scenario we are trying to get at from B point to C point, whereas our clockwise become anti-clockwise and anti-clockwise become clockwise, okay. Now so in the B point, origin will be the B and the limit is 10. The total space is 10 meters, so it is 0 to 10. So now we also drawn here one section which is X section, okay, with a distance of X, right? So now in this section we only need to take the moment, okay. So what will happen is just take 300. Now see, this is going anti-clockwise. VB, okay, it means VB going anti-clockwise, but it will act as a positive. Why? Because we are doing the backward calculation, okay. So VB, it means minus 300 into X, because we are taking movement at only this point, okay. We are taking movement at only this point, okay. At only this point we are taking movement. Understand? So So how it will be possible? See, 300 into x. So that's why I mentioned 300 into x. Okay. Minus, see, now clockwise, there is a UTL also. So clockwise will go 40x into x by 2. Okay. So this is 40x into x by 2 because it is going anti-clockwise. So anti-clockwise, okay, it becomes the um, negative for it. Okay. So minus 40x into x by 2. So my equation will be, okay, sorry, this is also going clockwise. Sorry, my bad. Okay, this is also going clockwise, right? So what will happen is, so 300x minus 40x into x by 2. So this become 300x minus 20x. Sorry, my bad. Okay. So 300x minus 20x square. How it is? 2 and 20. Okay. 2 ones are 2, 2 20s are 40. Okay. So 20x square. Okay. So yeah, right. Okay. So it is done. So 20x square over there. So you have 300x minus 20x square. Understand? Now you have the moment equations with you. So what you are going to do right now, there is an equation to calculate the horizontal thrust which is given by the integration value of moment into parabolic arch. So integration of movement equation into parabolic arch equation, which is m into y. So whatever you have calculated with m, you need to multiply with this y. Understand? Right? That's why we have calculate m and y equation. Okay. Now, what we are going to do is, first of all, take there will be two equation. First one with the 100x and another one for the BC, which is 300x minus 20x square. So integration of 0 to 10. Why 0 to 10? Because we have over here a limit of 0 to 10. Okay. So 0 to 10 we first take over this one into 100x, which is the m value. And what about y? So y is 20x minus x square upon 20. So this is we have written into derivative dx. Okay. Plus integration of the another one bc, which is 0 to 10 in bracket 300x minus 20x square into y value as it is into dx. Okay. So this is what we have written. Now we need to solve this. How we can solve this? It's very simple one, guys. You need to put the 10 in term of x. Okay. The higher value you need to put at the x value. Okay. And you need to solve it. Right. So just put into it. Okay. In your calculator. Okay. In your calculator, just you need to draw these equations. Put value x as a 10 and you will get the value of integration of m into y dx as a 5 4 times 3.33. If you just start, if you just calculating this in your examination, it will take a lot of time. So what I suggest is just in your calculator, even though I'll also make one video how to drop these equations in your calculators, okay, in Casio calculators. So that will helpful for you. Right. Okay. Now after that, you need to also cross check, okay, this value. So what we need to do is after calculating this, you need to again calculate one value, which is integration of y square into dx. Okay. So there is one formula for integration of y square into dx, which is 8l h square divided by 15. This is a formula. So 8 will be remain as it is. Okay. Put L value as a 20. This is the L value. And this H is the 5 which you have mentioned here. And 15 will be as a constant standard. So you will get integration of y square into dx as a 266.67. Okay. So what you have to do to calculate the horizontal thrust, there is a formula which is h equals to integration of m into y into dx divided by integration of y square into dx. So in that way you can able to get the horizontal thrust. So just put this value for this integration of m into y and 266.67 for integration of y square. So you got an h value, the horizontal thrust value, as a 200 kilonewton. Now you might be thinking that, sir, we have spent so much time in this numerical, but now we don't have that catch to check whether this value is correct or not. So don't worry, guys. There is a one catch, one check. which help you to calculate, to understand, yes, whatever you have done is correct. So there is a very simple formula to understand whether whatever you have done is correct or not. So this is a formula: h equals to WL square upon 16h. So h equals to WL square upon 16h. So put W value as a 40, okay, L square as a 20 square, which is a L is a total length of your span. 16 into h is a 5 because your central rise is a 5 meter, right? So you got 200 kilonewton. Okay, so whatever you will be calculating by this formula, you will be getting from this formula. So your horizontal thrust calculation is perfect. It's correct, 100% right. Okay, so that's the reason whatever the process we have done in this video is only for calculation of the horizontal thrust. If you just do in your examination this calculation, so you will get very minimum marks. Okay, examiner won't give you the that marks that you are expecting, but the thing is this sort of uh, tricks you will be helpful, that it will be helpful for you for the examination like GATE, SSC, RRBJ, and lots of the civil engineering services. Okay, so in this video I'm gonna stop here because this video is gonna more interesting in the part number 2, where you will be learning how to calculate the positive and the negative bending moment, which is the very interesting video. Okay, so I hope you like this video, guys. Don't forget to hit that button of the subscribe and visit my website www.civilnerds.com, and have a nice day, guys. Bye bye, enjoy your day, have a nice day, cheers, bye.